Alrighty. So I've been coding a lot today. Alright, so some cool things. We have collision. The problem is, okay, so I want to be honest with you here. My voice is kind of fucked. I think I just have to get used to streaming again because my voice naturally becomes unfucked. You know, when you sit here for like 8 hours straight just yapping for like 3 days in a row, your voice just naturally gets fucked. But like once you get like past like 2 weeks, then you're good. You're smooth sailing. Like your voice just gets used to it. However, mine is not there yet, so my voice is kind of fucked. But I'm gonna try my best to talk. But probably will be a little bit more quiet than usual because of the voice being fucked thing. So that's the first thing. Second thing is that we have collisions. Okay, so everything is working kind of properly. We do. I think we do have to make a better mesh to test against because right now it's kind of just like you fall off the world and then we have to kind of reset and put us back at the top. But for the most part, the collision is working. The only issue with it, so let's talk about the issue that we have with it. Okay. So the issue that we have with it is that the only way to get it working was to simply negate the normal at the end. So for those of you that may not understand what that means, it means that somewhere my orientation is swapped. Now you'd think that this would be a sort of easy thing to solve. However, it's absolutely not, apparently. And so I've sat here for about 3 hours now trying to fix it before I went live. Okay, so as you can see at the end of EPA, what we have here is we literally just negate the normal. So, yeah, I don't really know what the solution is, but that's it. I have this test here to make sure that our support point, or that, you know, we get a new support point in the direction of the normal and we get the exact same, the perfect distance that we got out, and that test returns true. That test returns true. You know, our D that we get matches pretty much very, very closely. So the math is correct. The problem is that the normal we get back is the opposite than what it's supposed to. And I, of course, have already considered, oh, is it just that we expect the other orientation? No, we do not expect the other orientation. We are adding the normal, right, to push out from the surface. And the unfortunate thing is that we just, it's not like we're subtracting the normal here, which would be the other orientation. The EPA is supposed to give us the normal, the surface normal from A into B, and we are A and the hole is B. However, it's giving us an exact opposite normal. So yeah. Anyway, I've programmed a lot in this section of the code base, and I feel like I'm at a point with it where we just need to give it a break, right? And move on with our lives. I'm going to fork it and save a copy of it, and then we'll just move on with our lives because this is the working version. And then we can, go forth in our lives, write our collision solver. That part will be fairly easy. We already kind of have it. And yeah, well, let's just move on with our lives. Like this is what I feel like doing at this point because I'm kind of like really sick of this fucking file. I'm not gonna lie. But all right, let's move on with our lives. So let's clean this up before we move on. I think that that's a really good idea to clean this up. I also have tried with both checking for just the horizon and then checking just for the opposites, which I did find an implementation that just checks for the opposites, which means how do I explain this? If you have a face on the horizon and it's A and B, right? The opposite face, if we're doing like correct orientation, should have the other points to match it, right? Since they're falling on that line. However, the collision was just slightly worse with that version. So I have no fucking clue which is the correct one, but I'll just leave a note here. It may be correct to only check the opposite orientations. So I'm just going to leave that note here so that we can get rid of that. Okay. Something else here is I was just making sure that we didn't have any duplicate points. I feel like we can pretty safely get rid of it. And this was a hard check to see if our normals were correct. And it failed sometimes. So yeah, I have no clue. Apparently our normals are fucked. Our normals are fucked on the inside, but it gives us the correct answer on the outside. We just have to flip the normal. So, you know, like I'm just gonna take the win and not go crazy anymore because I kind of have been going crazy. Not gonna lie. This file is just massive, and so a lot of things. Also, I want to make a macro here that that gives us, that just prints out for us. So let's think about what we want to do, because to be honest, I've been really struggling with printing for debugging. It's kind of a pain in the ass, you know, not using a debugger on this. So I kind of wanted to make some utilities for it. Just printing out a vec3 would be good, but I kind of want a system where I can kind of just pipe it into a buffer, you know what I mean? But because of function scope, it doesn't really work. So the way that they have it, for example, if you go into like Visual Studio 2008, like what I was using before, the way they have like their printouts to console is something similar that I would do here, right? Which is like you take in a char buffer, right? And then you just fill that char buffer with stuff, and then the, you know, outside of the function scope, then it prints, right? But I don't know about that. I have an idea. Like, what if we make a macro that prints out the variable name? That's easy to do. Nah, yeah. There's no like generic way to do it. I should just have a thing that just prints a vec3, for example. But I kind of wanted to have it so that you could put some text next to it, at least, or something like that. I don't know. Yeah, I mean, I don't think being a macro would be too overkill because no, it isn't actually. Hold on. The A, B, and C will be chars. Um, so we're just gonna print f, and what we'll do here. Can I do? Does that work? Does that work? I have no clue. But I'm just gonna do it. I'm just gonna do 0.3f for this, just to be as general as possible. And then this will be vec A, B, and C, which will be either chars or const chars. Does that work? And then put the new line at the end. Let's try and do that. So instead of this, we can't do a non-vec3 because the way it works. Why are you gurring? Why are you gurring? Can't pause is actually a vec4 for reasons, for UBO reasons. Those are the reasons. So I'm just gonna put it into a vec3. It's saying that I already have a can't pause. Where? Oh. What? Oh yeah, what the fuck is wrong with me? Okay, so print vec3, which is what we just did. We're gonna call it can't pause, and we will put X, Y, and Z in there, as they need to be const chars. Format specifies double. Does it? Does it? Oh wait, yeah. Yeah, I didn't actually put vec.a. Vec.b. STL user you're supposed to be using for your Windows. Is that true? I don't really use the other features of. Oh, actually that's X, Y, and Z, right? All right, let's give this a shot. And we are printing out. There it is. So that's the macro that prints out the name of the vec3 and then the vec3 so that we can see it. So now we don't have to ever worry about anything ever again. Hello, dustmite. How am I? I'm all right. I'm glad that we don't have to do any of this EPA bullshit anymore. I'm calling it quits. I got the correct answer. I don't know how correct the correct answer is. I mean, so it's correct. It's correct. It's just that the normal is flipped. For whatever reason, the normal is flipped. Our traversal is correct. It's just that the normal is flipped. So, yeah. Also, I think our safety should be lower personally. But what I'm doing is I'm just getting rid of shit now because all of this was really to check things. Also, I tried this both ways with flipping the normal only based on distance rather than the dot. Because you can't even trust the centroid anyway, so it's like pointless to trust the centroid. Either way, I think the code works. Some beginner questioned me in the Discord about Win32. Looking through his messages, joined a week ago. Don't you write a Windows library for... Yeah, Win32. That's cursed. I know because I did the Lenia project. That's cursed. It's so fucking cursed that Windows has, like... Why is it so hard to have wide characters versus non-wide characters in Windows? It makes no sense in terms of like they have two functions for everything in Windows, one with ASCII characters and one for wide characters. And it's literally just every single fucking function has two versions. Which state do I live in? I don't usually tell the state, but it's I live on the southern East Coast. So it's 1:30. Guy's gonna spend 500 years. Yeah. Win32 is fucked. Okay, so either of these ways work, I think, but I trust the centroid. You know what? I used to trust the centroid a lot, okay? And now I don't trust the centroid at all after what I've experienced this morning. I've decided that the centroid is canceled. We're canceling the centroid. Because a beginner, you should just use GLFW. Yeah, I mean, that's what I'd recommend, right? But also, maybe he just really wants to, like, learn the Windows shit. You know what I mean? Alright, this stuff I'll leave here. It may make sense to exit if we have duplicate support points. Okay, so before we move on from EPA, we need to transpose what we have currently into support points that all have data. Right now, our support points are just vec3s, but I think our support points also need A, B, and the diff, right? So our support point will make a struct for it. The problem with it, right, is that it'll just be on the outside, and then we'll have a specific other thing that we pass to expand whole that will count as the vertices. But we need our support points separately because it is apparently important for collision resolution stuff down the line, like fancy stuff about like contact points that I've never touched. So I have no clue. But apparently that's something that I need to do. Doesn't want to look like a cheater. I mean, I write things from scratch in C, so I guess I feel it. Hey brother, what's up? Long time no see. It's 1K subs. Can't remember, but it was the early phase. Thank you. I appreciate that. Yeah, it's been a long time. I mainly do streams. I feel like I could probably have grown the channel more if I made more videos, but I don't really like to make videos as much as do the streams. I enjoy talking to people, to be honest. 10 p.m. 3 a.m. Yeah, it's crazy. Like I've always streamed like at regular normal human being time, except for like very rare occasions. And normal human being time, what? I mean normal human being time here in America, like, you know, regular during the day. But what I meant to say is that I usually don't get any Americans, which is surprising to me, considering that I stream during the day. That is pretty surprising. Oh. All right. I I don't know. I want to call it a support vertex, even though it's supposed to be like a support point. I just don't like point as a word. I just think it sounds goofy. Oh my gosh, what is that lag? I think that's when it autosaves. I get a bit of lag. Oh my gosh, what is this lag? That's annoying. I don't know what was that? This is a dustmite. It is. Hi, Lily. C vibe. Yeah, C vibe is good. I'm a normal person. I stream during a normal time. I stream during a normal time in a normal day. Right. You're just gonna be a dick. That's all right. Yeah. Just do this. What am I doing? Okay. So I might have to restart the computer. Like, what is that lag? The fuck? I mean, to be honest, the computer did get left on overnight, and I haven't really reset it, so that is a part of it probably. And we do like let's be honest here. We do have a lot of buffers open. That is gonna be a thing. Okay, so the problem is, right, so we have this vector vertices, and so I'm just thinking instead of casting it to a vec3, we just cast it to support vertex. Oh no, because this vertices is the vertices that get used for the expand whole stuff, which uses vertices and not support points. I'm trying to okay, so here's the thing, right? I'm trying to find a way to get around this where I don't have to have two vectors here, because vectors are expensive. We all know that. Because this is our collision logic, and it feels massive, and that's probably because it is massive. Like your mom. Who's number one? You're number one. Don't know anything about coding, but I still love watching. Thank you. I think that's like the biggest compliment that you could give me, to be honest. That you don't know my language, but you still like watching me. I mean, that's like the biggest ego boost that I've ever experienced, to be 100% honest with you. Now, I could make two different things. I could also make the vertices on the holes. I could make them support vertices. I could make them support vertices just so that I don't have to duplicate the vector during runtime, which sounds like a very shit thing to do, just personally speaking. Okay, so let's make sure. So our vertex array during GJK, or during our incremental hole generation, we have points, and we use the mesh hole vertices. So if we just change mesh hole vertices to a support point, which I kind of don't want to do, then we could do this. The other option is that we could just rewrite the functions for EPA versus incremental hole generation. God, I hate making this choice, because it's a matter of performance. Like, I need to do it this way, or else we're gonna be fucking with our memory way too much. Shit. Us normal people remember with our normal language. Yes, we don't put U's in shit. We don't put extra E's at the end of program. If we give you a Python script, can I rewrite it in C? You're too lazy to learn C. That C is such an easy fucking language. I don't understand why you think it's hard. Yeah, that sounded like a very mean thing to say. It is easy though. Like it's just not hard to learn. It's like, dude, like it's just like I mean, doing this is hard, okay? But this has nothing to do with C. This is just it's just difficult, you know? It's just, you know, just a pain in the ass. But like you feel me? Pay me $5 bajillion. You don't have $5 bajillion, but if you did, I would do it. Dude, am I ready to write .p on every fucking thing for the rest of this for the rest of like this program's lifespan? On our whole vertices, we have to do .p on everything. Am I ready for that? And all of these fuck. Okay, fellas. Listen. I changed my mind. I changed my mind, okay, for a few reasons. Because I don't want to overcomplicate what is already some of the most complicated fucking code I've ever had to write. What we're just going to do is we're just going to have another array, okay, that we're going to make during runtime. And it's just going to be, this is normal people optimization code. This is what normal people do, okay? So I'm just being normal for once, okay? And just taking the easy way out. So if anybody wants to write the collision solver themselves, then, you know, feel free. But I'm not doing it. I'm not fucking doing it. I'm not refactoring that. It's putting the JSON in the wrong folder. Okay, did you do // and then put the folder in? Did you try turning it off and on again, or are we just being a bit silly? Okay, so something interesting. So this is supposed to be support A, support B, and then so yeah, so just the diff, right? So support diff should just return, instead of a vec3, a support vertex. That's what I feel like, right? And then we'll have support vertex p, and then p.a will equal this. We don't need to put offset into this anymore, which is excellent, because I learned that we can just apply it afterwards, after we do the dir, which is perfect. And then we just want to do the b with the negative dir. Yeah, with the b offset. And then we will do p.p equals p.a p.b. And now this will give us a support vertex with all of the different things in it. I almost forgot to return p, and then we would have been here for a while. Okay. So this support is not going to be a support. Thank God. Playing that role fucking sucks, by the way. Shout out League of Legends. It's supposed to be a session var, but it isn't. I don't know what you're talking about. Is this by NDC? Oh. Yeah. That's not a real language. Dude, when somebody spells color with a U, it's like actually it tilts the fuck out of me. Not to be that guy, but like, come on, bro. Like, that shit ain't normal. Like, that's just not it, bro. That is not right. Okay, so like I said, we're doing two different things here. It is not. I think you got it all the way backwards, bro. What's my favorite color? I don't know if I have one. Not to be like a dick or whatever, but when people ask me like what's my favorite color, like internally, I just like am like, yeah, I got no clue what it would be. I think I like green, but then like, am I just saying green because I want to like be special or whatever? A hair in my fucking mouth. That's the problem with having a beard. You just get hair in your mouth just randomly. That fucking blows. When will you try Steelix on my Codebox 3001? I'll try Helix when I go through like a mood where I'm just like, oh, it's time to customize. You know what I mean? I don't get moods like that very often, unfortunately, but next thing is that our simplex is actually, instead of going to be made of points, it's going to be made of support vertices. So yeah, that's kind of a pain in the ass. And then we have to copy a lot of those. Oh, yeah. That's disgusting. That's disgusting. You hate to see it. You hate to see it because now we're fucking copying 3 vec3s instead of 1 vec3. Why don't we have more errors? Unknown type name support vertex. Oh, I put it under the thing. You need blinking cursor. That's funny. You're forced to write bold? Oh, because of frag color? Well, at least someone knows the correct way to spell it. I just can't believe that that's like the correct way to go about it. You feel me? That's just, listen, I went to school here and they taught me that way and it just seemed right to me and I've always been saying it that way. So whenever it puts a U in it, it was like, I just like look at it now and it's just like, it's just extraneous. It's pronounced the exact same way, okay? So why do we need a U there? Like let's get fucking serious, bro. Because like let's get fucking serious here. Like we're not being serious here. S points A. Uh-huh. Dot P. Dot P. Dot P. Dot P. Okay, Helix is the best. Helix, you're the man. Are you kidding me that we can do that? That's crazy. That feels like cheating. That feels like cheating. Cheating. You're cheating. Like, what? Like, bro. If I was new to programming and I saw somebody do that, I would be like, holy shit, I want to program right now. I'm about to become a programmer just so that I can do that. I need to learn coding. Should I learn C or C++? And Lily said C. Okay. Well, it depends if you want a job or not. So, there's going to be two different answers if you want a job or don't want a job. You feel me? If you want a job and to contribute to society, you should probably learn C++. But don't let anybody tell you that I said that, okay? Isn't C like the old version of C++? C is still very useful for embedded stuff and low-level stuff, right? It's even better than C++ to some degree. Although some might say that there's zero, negative overhead abstraction and all those fucking, hype terminology or whatever. Like, at the end of the day, C is as fast as you're gonna make it. You get what I'm saying? And C++ you kind of cheat because the standard library has everything in it for you, including like the fastest sorting algorithms in the world. You don't have to implement any of that yourself. So that's why C++ is good, because you barely even need to know how to code if I'm being completely honest. That's kind of the best thing about C++ is that you don't really need to learn a lot of the coding stuff that is in C. But that's what I find really fun about C, is that you have to learn about all that stuff. So, do I know C++ too? I know a lot of the modern features, sure. I did like a bunch of exercises and stuff to learn that stuff, but in terms of like if I would probably like jump on a team with a bunch of C++ template users, then I'd probably be like, what the fuck is this, But I would I get the gist of everything, yeah. But there's there's a lot of things in C++, so it's kind of hard to. And there's also like a lot of niche things about like project structure, right? Like when you're building a C program, you really just have simple ways of building things. In C++, you can build insanely complicated systems that interconnect. So reading and understanding C++ is quite annoying for me. Yeah. Which language do I know besides C? I'd say I know C++. I know Java. I know Python. I know JavaScript. And Rust. But I haven't used the other ones in a long time. So, but if I was reading them, that I would understand what's going on, right? Okay. So I think I ported everything over fine. The only downside here is that at the end of the day, we do have another vector that we do have to deal with being allocated. That's a big problem here. This is very expensive, right? We have all of these vectors that get mallocked and stuff, and it's a total. There's a lot of churn happening here. So I don't know what system I'm going to go for afterwards, I'm thinking that it's hard to know how many points are going to be on the polytope. So it's not like something where you can just not, I don't know. Everybody's like, arena allocation, but in this case there's so much moving memory that arena allocating might, you might end up running out kind of space. Yeah, there's a lot. Do you go to college or are you self-learner? I didn't go to college for computer science. I just took AP. So I dedicated to learning languages. Yeah, I can't stand the long videos on learning a language. To be honest, they bore the fuck out of me, and I think that they spend way too much time on basics. I would recommend going to these websites where it's like, leet code but not shit. Like it's like websites where you can do like the exercises or whatever to like implement algorithms and things like that. That I think that that's a if I was to recommend like how do I want to learn a language and I don't want to do a project, that's what I would say. That is what I would say. Okay. Okay, so now we have our different support points. I don't know what to do with that information. It's apparently like some dumb bullshit. Not some dumb bullshit. It's supposed to be like something with contact points. I don't know. I have no clue what it's actually supposed to be. But as you see at the end here, we just negate the normal, which is whatever, and we free 6 buffers at once. Like if Aria was here, she would be like fucking livid. By the way, she would be like, "What? This isn't the dustmite I know. Fucking 6 vectors that you're all freeing at once." That's not the dustmite I know, but we're still here, so it's whatever. I probably will have to clean it up later, but I don't know how I'm gonna do it because you kind of are just going in a while loop and finding faces. That's what it is. So doing that without reallocating it all the time is kind of a challenge for sure. But that's all right. Okay, so I refactored that. I don't know what we're gonna do with that information, but it's time to just get rid out of all these comments and debug things that we were doing. Yeah, GJK is the part that goes super fast. GJK is like insanely fast. It's the EPA that's quite slow. But that's why you only want to be doing EPA like very few times. Like right now I'm doing it in a while loop, which is probably not what you're supposed to be doing. I was thinking of adding like an epsilon to p.d here would probably be good so that you just don't go into it again. Anyway, also what I want to do is I want to make a new mesh that isn't a cube so that we can walk around on it. We also don't have the ability to move yet, so I'm trying to figure out like what we're gonna do there, because we resolve collisions but we don't actually move. Oh yeah, because we go proposed plus the normal. Maybe instead of using proposed, we just use the cam pause. Oh no, but proposed is if we're going into the surface. Yeah, this pushes us out of the surface. The way I did it here was I did this. I projected it onto the wish. Would you recommend a font from Old School PC Font Pack? That's what I literally told you to download yesterday. So I don't know if you're rage baiting or what. I think you might be rage baiting me, but also I want you to do the command font. Can you do exclamation point font for me in this chat? Do exclamation point font for me in this chat. I might do it for you if you don't want to do it, but I recommend you do it. Okay, I'm glad that you did it, because you did it the other day, but I guess you've forgotten that you did it. But that's all right. I just wanted you to know that we already had this conversation before, and I told you to do exactly what you're doing. So that's all right, though. In fact, I was known for using the Trident 8x16 font for the history of this channel for like the past 2 years or whatever. I like how you think out loud. Anyone trying to learn C can learn a lot by watching. Thank you. I appreciate that a lot. I think that I'm like kind of scatterbrained a lot, so that gives me a little bit of hope for sure. So I appreciate that. Okay, I have no clue why this isn't working. I'm looking at it and I'm not getting it. Maybe if I get rid of the vel.n. I mean, it... That might make things funky. I'm trying to make it so that we don't... It's hard. It's tough. I don't have a way to scale objects up, by the way. So there's also that sort of problem. So I think the best way of moving forward here is to just like create something in Blender. Now I'm not a Blender expert, so we're just gonna pretend like, you know, I'm not a Blender expert, right? So that's not real. Can you? Thank you. Really, we just want a flat surface. So that's what I'm gonna make. Well, not a flat surface, but I want it to, you know, that's a slanted surface. There we go. You know what I could do is I could just literally just like grab a face and then extrude it. So I don't really know what I'm trying to do. Give it like, I don't know anything about Blender, obviously, but if it's even slightly slanted, then we're gonna fall off. Probably. Alright, now let's just add like fucking loop cuts everywhere and make it weird. How do you what's the, is it alt? No, not that. Is it alt? Oh, you just click and hold. You just shave your beard? Yeah, maybe. I'm kind of lazy is the problem. I'm lazy and they hate me because I'm lazy and it sucks. It fucking sucks. It blows. It blows. Now this isn't like... I think we've made a concave hole. Uh-oh. Okay, I may have not paid attention enough and accidentally made an illegal hole. Yeah, we may have fucked up. Let's just try this one out. Why not? Let's just give it a shot. Show wallpaper. It's black. Can you fuck off? No, cancel. Alright, I'm gonna save this. And export this as that armed. We're going to triangulate it, and we are putting it in here, and we are calling it Untitled 2. Okay. What is Z-bar and glaze? That's our window manager. That's how I'm able to do this. Okay. Okay, so we're gonna load in the third thing, Untitled 2. And we are going to put it into, we're gonna incremental hole the third one, and we need to make sure that we render it, because right now we're kind of hard coding the render for things. Right now I'll just go 2 instead of 1. So we'll render that instead of. Motherfucker. Are you kidding me? Okay. Alright, let's export this with the correct orientation. So up axis will be Z, and the forward will be X. Okay, we spawn inside of it. Okay, so that's not good. That is really not good. Okay, let's try our hard collision again so that we know that we're not just, it's not just sucking. Okay, there we go. We slid off of it. We slid off of it. Okay, so that's what we wanted to see. It's really not, it's really fucked up. I think it's because we didn't, it's not a convex hole. I'm a blender god, fuck off. I think it's not a convex hole is the problem. I should really make something that just like renders a mesh. I don't know why I didn't make a thing that does this. And just uses its vertices to draw. I don't think that we have. Oh, do we have indexed set up, or is it not? We've tried indices 0, 1, 2, which goes into current mesh vertices. So our try indices, which is our current mesh try mesh face. Okay, so let's just cast that vec. Let's just cast that vector. Mesh tries. Oh. Wait, what? Member reference type vector pointer? Okay, there we go. Okay, so we have our tries. Go through all of the triangles. Now I need to figure out how are we going to do the abstraction for the buffer. I think what I'm going to do is I'm just going to hard code GLUint that we're just going to VBO, and we'll just take that in and just bind it and fill it up. Hey, what's up, Snowball? Right now I'm just kind of hard coding a thing so that we can render meshes so that we don't have to look at the convex hole. I mean, although the convex hole is just what we should be caring about, we are kind of just gonna be sliding though, is the thing. Here's something. I have an idea. We never hit ground. That's the problem. Our problem is actually in our collision. That we never hit the ground. And we don't know when we hit the ground. Maybe something with a positive Z normal causes us to hit the ground. At least for the testing thing. Let's do it. If p dot normal dot z is greater than let's do 8. Hit ground equals true. Ground hit. Ground hit equals true. And also the player dot cam on ground equals true. Let's try that. Okay. We're extremely slow, but okay, so there appears to be a problem. I don't know what the problem is. I mean, so this is working, right? If our normal is high, then we hit the ground. And then our ground, our gravity isn't applied, right? During this stuff. Apply planet velocity. We are really slow, but why is our air acceleration so much? Oh, maybe because we have 18 as our thing. Our gravity is super slow, but this 18, our Excel, might might matter. Do we even use it? Do I even use it in this code? I don't think so. So it's not that. Yeah, it's not that. When I hit ground before, I had different code that got ran. I don't know if I have it here though. Yeah, I don't think I brought it over. Because I kind of wanted to do it on my own. Do I have a motorbike? Why? No, I don't. Why do you think I would have a motorbike? Wonder why our speed explodes. That's what matters to me. Maybe it's our gravity that's still high. But our gravity is so low here. Unless I specifically don't use gravity. I apply it twice sometimes. I mean, we could try it even lower and see if that changes, like, literally anything. Oh, I don't have anything that makes us leave the ground, do I? I don't think I have anything that makes us leave the ground. That should be an input, I think. Oh no, cam.onGround is false. I think I also need something that checks if we're off the ground or on the ground, though. I think fixing would fix it. Thank you so much. I really appreciate that. It seems cool, a motorbike. Yeah. Yeah, I agree. Okay, how about this? How about this? Let's just really strip back the movement code, because the movement code we can be completely honest here, is quite ridiculous and ridiculously complicated. So let's just like really simplify things down to their basics, because we don't need any like wish direction, anything. Okay, well, maybe. We are moving around properly, but I think the apply air acceleration is pretty scary, and this this way of capping with the... Hey, what's up, Prod? Nice to see you. Yeah, now our movement is a bit more normal, I suppose, but maybe the normal isn't greater than 0.8 there. Let's see when we hit the ground, and let's just do that. I think getting rid of this will be nice, but yeah, let's see when we hit the ground. Okay, well, obviously that's not gonna tell us anything because been a while. I haven't gotten a haircut. Yeah, I haven't really bothered. No, we do hit the ground there. See, we do hit the ground. Can you watch Kill Bill? Baby. I'm not like the biggest Tarantino guy. We hit ground a lot, and that makes sense. Our collision code works. It's just sometimes that we slide off. Like that. Having ground friction would... I do have that already, actually. I have friction. This is our friction. 0.85. I'm not sure. Ground friction? I have ground friction, that's what that is. Maybe, oh, yeah, maybe not rely on SLen because now our speed is so low. So either make SLen like ridiculously low Or, yeah, maybe that has something to do with it. He's relying on slen when our constants are this low. It's probably has something to do with it. What does our camvel get? Our camvel doesn't get touched by anything when we resolve collisions. So it has nothing to do with that. It has to do with Let's get rid of all of this. Oh, but then we don't have... Yeah, I don't know. Let's just make the vel just a raw wish instead of doing any acceleration. Stop the instant slipping. Well, that's what we're trying to accomplish. Okay, so that's not okay. This seems to have worked. This does seem to have worked. Okay, yeah, now we're not slipping anymore. Why Tokyo Night? Because you didn't want me to use my own theme. You were like, oh, I can't see anything with my theme, right? And so that's why I changed it. That is why I changed it. Okay, well that works. It turns out that it was nothing to do with the collision detection, but this rather. I wonder. So the idea is I don't want to keep this if possible. Or maybe I do. The idea is to eventually have this, but if I turn this on right now, then it's not gonna work, I think. Oh, actually, this seems fine now. Now we just kind of slide around on the surface and pick up speed, which is what you typically want. And you also have these bumps, which are you kind of jumping off the surface because you're sliding and then projecting off. I want to do something which will help us a bit, is to when we do a hole, what I want to do is I want to make it so that it's triangles rather than the raw. I want to do triangles rather than the raw lines. Lines is cool for debugging, but I would much rather the triangles. The reason why the triangles are good is because we can put normals on it and then light it so that we can see things better. That's so bad. Go back. It's so dark. It's dark, but the text is light. So that's the whole point, is that there's contrast so that you can see things better. So instead of vec3, it's going to be ×2, right? And then the triangles buffer will be main vertex. The points aren't vec3. Oh. Actually, no, the vertices don't. Okay, so then instead of going through this, what we'll do instead is we'll go through the whole dot faces. Right, yeah. And this is mesh vertex, mesh face. Oh, I already have this. What what is wrong with me? This isn't a vec3 anymore, is it? No, it is. It is. So, oh, it's inside of the indices itself. It's inside of the trie itself. Yeah. Okay, so then at the end, what we want to do is have the vec3 for normal, I think, right? And for this, you don't want the offset, obviously. And the points... Okay. We want vec3 add... Okay, so that gives us the normal. The problem is that we need normal after each vertex. So that's the other thing that we need to do. So the first one will be that, and then that'll be after the expand. And then you expand again, and then that will be after that. And then you expand again, and then that'll be after that. We don't have per vertex normals or indexing. This is just kind of raw, right? And so you'll draw this using GL triangles, and we won't be doing the wireframe. We'll just be doing this. Okay, and hopefully that shows us what we want to see, because now we'll draw the okay, it does seem to be a bit broken. Let's just see if the normal is fine, is not fine. by just doing this. Okay. So now the question is, is the issue with my rendering, or was it always wrong? Oh, hold on a second. This is... Oh. This is supposed to be a main vertex. And that's why I was confused, because we don't need to be... We need to just be doing like that. Oh, I fucked this up. I should be making this like a reusable thing rather than something that's only used once. So that is kind of my fault. I'm glad that this is the bug and not something else, because that would be disastrous if it was like the actual... Oh, fuck. Okay. I fucked something else up. Oh. Whoops. Because we're expanding it every time. Okay, there we go. It's see-through because that's what the code tells us to... What I told the code to do. With, okay. Oh, it's probably my normal... Yeah, okay. So this is the vertex holes themselves. I need to make the no-clip thing a toggle. It keeps on toggling on and off when I click the button because... Seems alright for now. I'm kind of noticing that we don't really stick to... Yeah. Like if I jump, then we'll fall off, but we don't actually have a thing that figures out if we are in the air, per se. Because we can just walk up a surface and then walk off, and then it will still be on the ground, right? Let's see how I fix this problem in my other code base. Didn't I check the ground underneath or something? This is an interesting way of going about it. I said cam data dot camvel equals wish. Ah, shit. Now that's not actually going to solve the problem that I was just talking about solving, but like, yeah, we don't. Yeah. How did I do it in my other code base? Ground hit equals false. Hit ground if this to floor. Ah, so if just no collision. Okay. So just have this after one iteration. Okay, that's more like it. I need a reset button that puts us back at origin. That's what I should do next. Should also make the no clip thing a toggle for sure. Yep, and now we are starting to slip. Perfect. Just slowly starting to drift to the edge. It is a bit bumpy. The reason why it's a bit bumpy is because I have an epsilon. So let's try and get rid of it if possible. What am I encoding right now? A game engine, I guess. Oh my gosh, what the hell just happened? What? What? Yeah, so I guess a code engine, a game engine, but more so like I don't know. I have an idea for a game where it's kind of like you're not really playing the game, but the game is kind of playing itself, sort of thing. But I don't know if I'm gonna be able to finish it because I kind of suck at modeling and stuff. But I made a game engine before, and you know, it was kind of janky. So I want to make one that's good because I think I can make a much better one. So I'm just working on Collision right now, implementing GJK and EPA, which I never did before because my old engine was kind of jank, and I kind of just like winged things. But now I'm just like kind of doing them the proper way, or at least trying to. See, this. So now we've asserted the problem here. Interesting. Interesting. I like to work with perfect numbers. So I don't like things that are like if p.d is less than some epsilon. I prefer, because now you're gonna get like bumpy stuff going on, which I don't really like. But the reason why that assertion is failing is because the d becomes so close to 0 that it's a problem. Actually, no, yeah, this assertion failing is bad. Is there a particular reason I use Windows? Yes, because this laptop is very old and very shit. And so what ends up happening is that I have to have very specific drivers for the NVIDIA card that's in this thing, and they don't have them on Linux. So that's the reason why. Until I get a good computer, then I can, I think that it's pretty common for people to have this misconception about Linux, because I don't think not a lot of people work on really, really old hardware, but it's kind of not good for old hardware to be on Linux. It kind of sucks. I'm just trying to figure out why this assertion is failing. Yeah, I gotta make a reset button. Actually, yeah, let's just do this right now. Do we have a... Let's just have a spawn point? I don't know. And we'll just put this in here. Trying to learn graphics in C++ and Raylib. Got any tips? I've never done Raylib, but I think it's I don't know if I have necessarily any tips. Like just like general tips. I'd say, honestly, the rendering and the graphics stuff isn't that hard in terms of graphics programming. I think like the hard stuff is everything that it interfaces with. That's what I think. All the graphics programming, all the shaders, all the lighting is the relatively easy stuff. I think like the systems that everything interfaces with, like collision, mesh, whole decomposition. I'm just thinking about the stuff that I've done, recently. It's pretty insanely difficult. I mean, rendering for sure is difficult as well, but yeah, we're doing a lot of like talking about acceleration structures and stuff like that as well recently. So I'd say that getting your feet wet with any of that stuff should be really the goal. I don't know if I should even be using Raylib. I'm using OpenGL. If you have a new computer, I'd recommend you use Vulkan. Probably. But it's up to whatever you want to do. There we go. I'm one of the people that just like, I don't think it really matters. I'd recommend you do Vulkan. Scares you, it shouldn't. Vulkan is not harder than OpenGL, despite what people say. At like a high level, once you get to the actual stuff with Vulkan, there are things that are way easier in Vulkan to do than in OpenGL. It's a common misconception by people that think like Vulkan is harder. Sure, to start off with, it's more complicated, and you do kind of need to know your way around, but later on, OpenGL is just incredibly difficult because you don't have a command buffer. So, most of the people that say that, I don't think that they know what they're talking about, to be honest. Why would this be causing that assertion fail? Is it really just you have to add an epsilon to p.d? Is that really? Maybe it's I just have to add an epsilon to p.d, or else we get caught in like an infinite fucked loop. I understand that once you are handling multiple games threads and such, OpenGL is hard, but the setup is too much. I disagree. I mean, the setup with OpenGL is the easiest part for sure, but the setup for anything is, I don't know, okay, so this is the thing. Like, so eventually you're going to get to a part with your rendering project, especially if it's going to be like a game engine, where like OpenGL is going to be fighting you every step of the way with the stuff that you need to do. That's the hard part. The setup, who cares about the setup? Who cares about the first 2 days? Like, the hard part is the rest of it, So I think most people with the experience that they're looking for should probably just learn Vulkan. That's what I'd recommend. Because setup is nothing either way. Setup is incredibly easy. You have to design structures, but they literally have a flow chart of all the structures you need to design, you know what I mean? So it's like, yeah, that's a weird thing. Yeah, we only start going down when oh yeah, because we stopped validating this, right? There are levels to it. Yeah, I mean, I guess that's just my like recommendation though, based on Okay, so we aren't going down. Oh, maybe it's this. Oh yeah, it was definitely that. Oh wait, no it isn't. On ground equals false. If not on ground equals false. Only if not on ground. But we shouldn't be. It should be on ground equals false, and then we shouldn't be getting a collision. So why are we going through? Like, I bet if I just like left a print statement here, it's gonna come back even when we're not hitting the ground, because that's the only way we wouldn't be. Oh no, we aren't. Okay, well then that has to be something with my velocity update then. That's the only way that it would be doing that. I don't know. If cam is on ground, okay, so this once again is S-len, maybe had something to do with it. Okay, now we're not applying any velocity. Oh, because I have this return. that would be why. That would be why. Okay, well, I think I fixed something and then broke another thing. Yeah, the air acceleration is crazy. But I think I fixed the problem that I was trying to fix. Or no? Oh yeah, I did. Now we can fall off. So this S-len isn't something that I should be even worried about because the numbers are so incredibly small. Maybe I should have made a constant for that in my other engine so that I could deal with it. I think that this is supposed to be if the S-len is small, then we are applying friction. But what it ended up doing was just not applying gravity. That's why I had this code here, which is probably what we should just have in general, and then just have this deal with friction. I think that that's just a good way to go about it. The air acceleration is crazy. I think that that's just because of the constants. Yeah, I mean, there's a lot to toy around with here. Holy fucking shit. Why is that so crazy? Dude. Yeah, when you leave the ground, you speed up like a lot because of the friction. Uh, I don't even have this. Oh wait, I'm adding the wish twice. That's probably why. Okay, this is way more reasonable, I think. Okay, yeah, and then you hit the space bar and then you fucking fly. Oh, I don't think I'm scaling back to the max speed. I think that that's the problem. That's probably the problem. Yeah, that was definitely the issue. Okay, now that we've figured that out, now back to the code down here that I was initially trying to figure out. Right, so I did this, which I still don't know if I'm supposed to do that. I thought that I could just go like, you know, like this, and you know, we just don't have collisions when the depth is that low. But then we get this assertion fail. I think that there's an edge case that I'm just not aware of. Why would this cause it? I may need to do some printing out of some stuff here, I guess. Let's just see what D is. I know where the assertion is failing. It's just I have no clue why. Because where it's failing is 263, which is how we get the what am I fucking saying? How we get the polytope from the simplex. Just seeing if I did something wrong. I am using this instead of this. There's that. I just don't know why it would happen with that specific line of code. It's like the weirdest thing. I guess we can check the points. This is going to print out so much that it's going to be very hard for us to walk around. But I want to see what it is when we get the assertion fail. It's not giving it to me. There it is. Okay, so our polytope has the same point twice. Same point twice. Okay. Do we just detect that and then deal with it? Like, maybe I should Google this specific edge case. We get it from the simplex, so this has to be a GJK thing. If it pulls the same point twice into the simplex, then there's no collision. Okay. Then let's code that in, huh? Where do I put that? Probably here, right? Add point to simplex support. Maybe this is supposed to be a less than rather than less than equal, but I don't think so. Okay, so let's try that. Okay, let's stop printing out all the other shit because it's making us slow as fuck. Uh, we're getting a couple of quality found, so maybe that was important for us to have all along, and I totally didn't know that. Well, that's good. That's cool. So now we can keep progressing with our collision resolution code. And go back to doing this, which is what we wanted to do in the first place. Okay, well that's not a good sign. Which times? Oh, I didn't project it. Why is it so high? And also get rid of this. Maybe I should look up how to do this rather than just winging it. I thought that p.d made sense, but maybe you're just supposed to use the raw value? No, because we're going through it. This is the same code that I used before. Yeah. I may have to look up how to do it. Yeah, maybe you just update the wish velocity instead of actually changing the, like we're doing here, instead of actually just changing the thing. Maybe that's fine. I think that that's what we're supposed to do. So I think that that's fine. That's cool. I have no clue how to do other things, like maybe like hitting a wall and going up it. I don't know. How to do the more complicated things. I probably have to look how to do that up. What I do want to do now though is hold decomposition, which is something that I'm very excited to try to figure out how to do. This is like the hardest part about all of this. It's going to make our thing that's a convex hole right now, that's a broken convex hole, into a concave hole by splitting it up into different holes. The tricky part with that is how do we determine which where to cut it. And so I've done some theory crafting about it. There are known ways to do it, like HACD or whatever, HVACD or whatever. But yeah, I have no clue. Yeah. So the tricky thing about doing the whole decomposition thing is that you need to clip triangles, and so we're gonna have to clip triangles. Yeah, I think. So I think that what we're going to do is we're going to start with the raw vertices. When we load in the mesh, just start from the raw vertices and the raw faces and those triangles. And then we will try to test if the hole is convex. And if it isn't, then we know we need to split it. I don't know how to test that though. Let me see. I looked this up earlier, but the 3D check each face's plane equation. If all of the vertices of the mesh lie behind every plane's face, every face's plane. Yeah, that's what I was thinking. So you do the point minus a face on the point, and then you dot it with the normal, and you check if it's less than or equal to 0. If a face's plane equation yields a positive result for any vertex, that face is concave. Yeah, and then from there, I think I'm going to take the normal of the concave face and just try and split the mesh at that point. Or something like that. But yeah, it's apparently hard. So the way I'm thinking about it, right, is if you have a concave face, there are probably like other, like if you cut it on the concave face just going through, wouldn't you want to just like cut it on the edge that intersects the not concave face? Do you get what I'm saying? Like if there was a V, don't you want to just like cut it in the middle rather than go through the plane of the concave face itself? Like won't it just cut better if you just cut on, like if you probably average the normals of these two together and then just cut in the middle? Because there's a couple of like, ways we can consider to do it. But yeah, so this is the part that's going to be hard. It's the mesh decomposition, and then we are going to split each mesh into multiple different holes and then run incremental hole on all of them, and then encase the whole thing in the BVH, which we did set up earlier. But the BVH is going to take the bounding boxes of all the convex holes and sort through them so that when we do collisions, we only need to check against the whatchamacallit, the relevant convex hull. I might just bother everybody and go flat white today. I'm feeling the flat white today. Most of the nobody on the stream knows how many lines are in this file right now, and that makes me feel a lot better. This file's getting there. This file's really getting there. I kind of want to get a coffee. I feel like I need another coffee to do this. Is that a crime for me to get a coffee? So the first step is to loop through all of the faces of the mesh and then cut it. And then recursively cut it until there's no concavity detected. You feel me? Yeah. So let's write this out. So we are going to cut on concave faces. Find using dot. Cut on concave faces. We need to also clip triangles. Fuck, bro. Our triangles are indices, right? So the difficulty begins to occur to me that okay, so we have a vector of holes that are growing. Inside each hole gets its own vertices. This is going to get really complicated. This is going to get insanely complicated very fast. It's so simple on paper. It's just recursively split, right? But this is going to get really complicated when we have to clip triangles and then basically change the triangles that that are shared between the two holes. Fuck. Yeah, that's gonna be hard. I'm thinking about how I'm gonna do that. It's good that everything's vectors, right? But temporary, okay. So temporary hole, temporary vertex indices that keep track of which ones need to be deleted and which ones are added. Okay, that's what I'm thinking of doing, right? Is that for each hole has its own list of vertex indices and face indices that we then add on to and replace. So that we can keep track of which ones are the final ones, right? And so we're only keeping these scratch buffers for the end, where we will then only emit the vertices that we use and the holes that we use and the faces that we use. And this will naturally deduplicate as we go along. First thing we have to check is, how do we load in our meshes? I need to know which array it's on. Tries are mesh face, and vertices are points. And that's going to be our master list of the originals. And then from there, we're going to expand and create holes in a vector, and those will have their own data. Okay. So let's just bring these to the top. These will be our original vertices. So we're going to cast vec for the tries, and we'll cast it to mesh face. Fuck. Cast vec. Excellent. Yeah, so this is obviously going to be mesh. Okay. So for each face, we need to do the dot test against every point. Does this have a normal? It does have a normal. Okay, we can use that normal. So what we need is the inside, which is going to be the sub of this current point, which we will get point, we'll have a vec3 p equals the point j dot pause, and we will sub p and the a point on the face, which will be indexed by point dot pause. And all we need to do is now get the dot of, what was that? The dot of this point with the normal. We can also construct that normal on the fly. I'm trying to make a debug shader, accidentally made bloom. Oh yeah, did you ever get bloom, get the Gaussian bloom going on? Okay, so we have the dot. So if the dot is it greater than or less than in this case? I can't really remember. No. It's greater than or less than. It says fully convex if for every phase all of vertices meaning less than or equal to 0. If the dot is greater than 0, then split. Then we recursively split downwards. I inverse the square root of my lowest distance on your ray marcher. Actually made it really crazy. Splits off. SDF bloom is expensive. Yeah, I have no clue about SDF bloom. I do have Gaussian bloom though. That was totally not just stolen. It's really just a kernel. At least my bloom is literally just a Gaussian blur. I'm not sure it's a real thing. I mean, why not keep it if it looks crazy? Can you tune it? So how do we know where to split? Because we could just take how to find direction vector on plane on normal face? The dot product of the... Okay, this isn't what I want. This is what I want. How to find direction vector perpendicular to plane normal. Choose a vector v and solve for the dot product. Okay, solving a linear equation. Mine off the distance from the surface. Your normal vector then. What the fuck? Let the normal set up the dot product with an unknown direction vector v. Solve algebraically for the third. What the fuck? Why is this so complicated? Finding the vector perpendicular to the plane. Find 2 points on the plane, then they both satisfy the plane equation. Any vector on the plane is perpendicular to the vector 2, -1, 3. Take 2 points on the plane, then they both satisfy the plane equation. The perpendicular. He knows what the perpendicular vector is. Pinged you on Discord of it of what I'm trying to do here. Oh, that's sick. Yeah, that does look like Bloom. That looks sick. Maybe I'm being stupid. Hold on. Maybe I'm being stupid. Hold on. Yeah, I think I'm being stupid. I don't even want to do that. I don't even need to do that. What I need to do is okay. So how do I determine what splits? I have to dot everything against this plane's normal to figure out if it's above or below it, right? If it's in front or behind it. Okay. I think I figured it out. Okay, so we take this normal. We take this normal. We need to figure out if it's below or above the plane. Bro, I don't fucking know. I think I have to take every point. You're doing an SDF render, then this is pretty much free Bloom? Yeah, maybe. That would be a lot of SDFs though. The Fortnite SDFs. The Fortnite Bloom? Get hired by Fortnite right now? Hey, you guys want free Bloom? I got free Bloom. Fuck. Yeah, it's sub the point. So to split, we just do this, right? We just do this. Wait, no. No, yeah, we don't need to do this. Because we already have... Yeah. We already have this. So all we need to do then behind points, and this will be we'll just make a vector here that we're going to push indices onto. And the SDF god. I think you are an SDF god at this point. Seriously. Okay, so now we have the indices. And then here we need to make sure that we free behind points dot count dot buffer. So we pick the points that are behind, and then we split it into two holes from here. So now everything that is behind gets a hole, and everything that was before gets a hole. You feel me? You feel me on this? Now, do I know how the fuck to split it into two holes right now? Absolutely not, but we're gonna figure it out. Okay, we have the indices of the behind points, and then the indices of the in front points. Actually, you know what? It'll make this so much easier if we just have two vectors, one for behind and one for in front. And in fact, like let's just straight up do the thing here where we put it outside of here and we just reset the counts every time, right? We just reset the counts every time. Behind points. Oh, the problem is yeah. The problem is you want to restart every time you split. So if you find a split, then you're gonna recursively go down anyway. So this is pointless. I mean, no, you probably want it out there anyway. But so what's gonna happen is that, you know, we're just gonna have a Boolean. And whenever we detect a split, that means that we're just gonna break out after this guy. Because you don't want to keep splitting, of course, because inside of here, now you're recursively splitting. Here is where we recurse. Oh. I think that we're doing it. We are just doing it. We're just doing it. Okay, so here's the problem. Is that so right now what we're doing is we're just splitting the vertices up, but we also need to clip the faces, bro. This is complicated. This is so fucking complicated. Oh, I don't know how to do this. Oh, shit. Ah, fuck. See, this is why they said it was hard. And I thought, oh, it can't be that hard. But yeah, it's hard. It's fucking hard. What can I say? So what's gonna happen right now if I just recursively split like as we have it right now, is that what's gonna happen is we're just gonna have gaps, right? Because we split in the middle here, because these are dotted this way and these are dotted the other way. But we were supposed to have triangles that were connecting those, and now we're just gonna put them in separate holes. Like, really? So we need to make new vertices on that plane. Okay. Now, so the brute force way that I'm thinking of doing this, right, is try and find every face that intersects that plane, and then split it at that point. Yeah. I have no clue how to do that. But yeah, we need to clip the triangles. And if I just go through and I loop through and I, like, try to see, hey, does this triangle, intersect this plane? It's like, if I make a plane with a D, if I get a normal and I get a D for this, right? Can I solve for an axis? We have to get down to the triangle level for sure. But then once we're at the triangle level, then where? I'm at the triangle level, checking all the triangles. A tough World Cup? Oh yeah, that's what's going on right now. I have no clue what's going on with the World Cup. I guess so. A triangle, we can determine that it needs to be split if if a point was dotted the other way, right? That's how we can determine it, right? A triangle needs to be. We need to clip the triangle if some points are dotted against the normal positive and some points are dotted negative. But how do I split it in the middle on the plane? Let me look this up. How to split triangle by intersecting plane. Find the intersection of the plane with the triangle's edges. That's what I want, right? Determine if the vertex is on the positive side, negative side, or exactly on the plane. I can do that. I can do that into the plane equation. Group the vertices based on their mathematical side. Find the intersecting points. Looks like plasma. That's sick. An intersecting plane cuts the edge where its edges across the plane. For every triangle edge, find the intersection point P. Line plane intersection algorithms. Oh god, this is going to get complicated, isn't it? You will form new polygons. Oh, fucking shit. This is gonna get complicated. You need to take the dot product of the normal with the viewpoint to obtain the offset. Okay, I don't want any of that. I want it in physical space. Group the vertices based on their mathematical side. I can do that. This is fucking complicated. Oh my god. Okay, clipping a triangle against one plane. Find the sine distance of each vertex from the plane using the plane equation. That we can do. Count the number of vertices that are outside the plane. If 3 are outside, discard the triangle. We don't have to worry about that. If 0 outside, keep the triangle. That's fine. If 2 are outside, make 1 new triangle. If 1 is outside, make 2 new triangles. Find the edge intersections for the 2 edges that connect inside and outside vertices. Okay, the new triangle connects the inside vertex and the 2 clip generated vertices. Okay, how do I get the clip? Vertices that violate any of the inequalities is discarded. Fucking Christ. This is not good. The new triangle connects the inside vertex and the 2 clip generated vertices. How do I find the clip generated vertices? Can you fucking put that in the thing? Okay, I think okay. I think I'm just gonna do line segments. I think I'm just gonna see the line segment. Can I do that? If I plug in the vector between a point and another point on the edge of a triangle that I need to clip, will that work? And then I just plug it into the plane equation and it gives me a D. Will that work? Clipping a triangle against plane 3D. Sutherland Hodgman approach. I think I've done this before. Calculate edge intersections. Find exactly where a triangle edge crosses the plane. Use linear interpolation. Okay. I think I've done this a long time ago. Clipping the scene against the plane. This is all like practical. Like I need a 3D volume, not a fucking clipping plane for a view camera. I need to clip an object. This is all view camera shit. Okay. Okay, we finally got it. Clipping triangles. Here we go. Only if every graphics program had a government-issued professional mathematician. Yeah, that would be sick. That would be awesome. So that I wouldn't have to read this shit. Oh my god, and he's putting it in fucking stupid... Oh, he does have code here. No way. Okay. Clip instance against plane. Finds the signed distance between the plane and the bounding sphere center. What? I just have one clipping plane. We really don't have to have like all these clipping planes. Oh my god, it's so fucking complicated. It's so complicated, and then once I write it down what I need, it's gonna be like 4 lines of code. But like, why is it this complicated? Okay, okay. We have a clipping plane given by the equation. The triangle side AB can be expressed with the parametric equation as P equals A plus TBA minus A for 0 less than T less than 1. To compute the value of the parameter T where the intersection occurs, we replace P in the plane equation with the parametric equation of the segment. Bro, like, this cannot be that hard. It really can't. I have a plane that is intersecting a triangle. I just need to know what the 2 points are so that I can split the triangle up. It can't be this difficult. It really can't. It really can't be that hard. It's really not that hard, man. Like, I promise you. But there's just one equation that I need, and it just like. Holy fucking shit. And this guy is in GLSL. Like, bro, get a life. Come on, man. Come on. It can't be that hard. It really can't be. It can't be. These guys are just talking about compute shaders, bro. Like, it's really, I just need one fucking answer. Okay, fuck this. I'm getting coffee. I'm losing my mind here. Get the fuck out. I'm not fucking playing with you. Get the fuck out. Come on. Come on, buddy. Come on. Come on, I'm not fucking playing with you. Buddy, come on. Okay, I'm locking you in. Get the fuck out. Okay, I'm back. This cat was fucking in my room making a fucking mess. Okay. Okay, so I fucking asked ChatGPT if it knows what I should do here, and it said to use the plane equation. So I'm just gonna steal what it fucking said and move on with my life so that I don't have to read like fucking 20 pages on this shit because I was losing my goddamn mind. The vertex minus the plane point and the normal gives us the D, right? We already have this. Jarvis tell me, yeah, exactly. Okay, so we already have this, so that's what we need to solve the plane equation. For each triangle, D0 equals the n with each vertex against P, against the plane point. If they're all positive, keep the triangle. If they're all negative, then you move it to the other hole. Make sign, split the triangle. So that's exactly what we're doing here. We are already doing this. For an edge AB, this is the part that we want. For edge AB, we split the intersecting edges. So, we'll do it per triangle. So this is instead of going by vertices, we need to actually go. We need to go by tri. We need to go by tri because, yeah, we need to go tri by tri. But let me just write down what the equation we actually need is. For an edge AB, it's literally just 2 lines of code. Di equals the dot of n with a minus p. That's simple. Which we already got that. And then the t which is, this is all that 20 fucking, you fixed that bug? That's awesome. This was what 20 pages was trying to tell us. dA over dA minus dB. Like this. And the final intersection, which is what I was looking for this whole time, is the point is going to be a plus t times b minus a. A plus t b minus a. Oh my fucking god, I just realized that, oh my god, I already have this formula. Oh my god, I'm so fucking stupid. This exact formula is exactly how I interpolate stuff in my linear stuff. This is exactly what I do in marching cubes, actually. This is just marching cubes. This is the literal function for marching cubes, by the way. Okay, so well, now we know, let me just make sure that I got it correct, the TB minus A thing. Yep, this is it. Okay. So instead of splitting on vertices, we need to split the triangles themselves. So this is actually going to be a nested loop of tries. And then we'll go per triangle, because we need to split triangles rather than vertices. Let's not call it T. I don't really want to call it P either. We'll just call it K. Okay, so the points, we'll go points. We need two triangles here, so we'll go tries. X, Y, Z for loops. Yes, you are. Everybody else uses I, J, K, or P. I use X for stuff inside of loops. That would be so cursed. Okay. So now we have phase A and phase B. And we want 1 point on this. So we'll call that vec3 P. That's what we'll call P. And this will be TA indices 0. That's insane. That's unhinged, actually. That is so unhinged. Okay. And now we want to count. Let's just call it normal, so that we're not jumping around in memory. Alrighty. So now we're in the fun zone. We're in the fun zone. Oh, actually, okay, so let's just... Nah, yeah, I mean, that's just cursed. That's just cursed. Because what if I want to float X, float Y, float inside of here? Like, that's gross. That's gross. Like, I is the industry standard. Everybody uses I. Or maybe it's just me. Maybe I'm crazy. I don't know. Okay. No, you use I first, then it's X. Okay, I is fine. Okay, as long as you do I, you can use whatever after that. J and K is the ones that I see most often though. Okay. So we get our dots. So if it's greater than 0, if I'm trying to make int X in an X loop, I just do int NX. I see. Yeah, I usually do the it after. Like, for example, mesh phase here, I did TA rather than AT. But that's just like a personal thing. Fuck. Yeah, I see that. That's smart. If splits is 1 or 2, then we have to find the edges that intersect the plane. Well, that's cool to have a system. Yeah, loading stuff from cache is pretty fast, huh? No. Can I figure this out while just using our DK, or do I have to recalculate it? This is complicated. I don't want to have a switch case here doing it. Trying to avoid it. Okay, so there's 3 of them, and we know that 2 are unique, and 1 is the odd one out. That's the only thing, right? So all we need to do is we need to check which one that is, and then do the edges that connect to that from the other 2 other ones. It's that simple. It's that simple. Oh, it's raining. Nice. All right, I'm going to be back in a second. I have to get my coffee. Oh, I'm muted. Thanks. Oh, that's without cash? Anyway, my coffee isn't ready. It's taking fucking forever to drip. So we know that there's 2 and 1. So all we have to do is just for loop. Oh, now we're deep. We can use K again. We need a for loop through all the points. And we need to know if dk doesn't equal dk plus 1. Okay, lag is happening. I like rain. Yeah, it's pretty awesome. Okay. So if there's a difference, then we need to split on that edge. Okay, and this is the part where the thing comes in handy. So we already have DA and DB. So all we need is the T, which is going to be, I don't know if it matters the order we do it in, but I think I'm just going to do the second one as this one, just to keep the ordering intact. Wait, hold on. You need, oh, that is DA. That will be DA. Really, I should do so that I don't have to type this again. Oh wait, hold on. No, I'm being fucking stupid. I am doing them backwards. Excellent. Okay, so now we have to remember which one is DB. So DB would be K plus 1 3. Your video is the top result. That's crazy. That is crazy. Okay, now we take the dot pause. And now we want to Alright, that's a whole hot mess of a function call, but alright, we have a point now. That's the point that splits. Now the problem is what we do with this point, because a point doesn't really fucking mean anything, unfortunately. Actually, I think it does. I don't think that we have to triangulate this by hand, actually. Since we have a point now, we could just pass it to the whole points. Oh, not really. I was gonna say we can just pass it to the whole points because we just do a point cloud and whatever, but the problem is then we can't recursively split down the tree because we need normals and we need faces to recursively split down. So we can't just do that. So what do I do with this point now? We know what it lies between. We know that it lies between DA and DB. And if we make another point on the other side, well, we're guaranteed to have 2 points, right? So then what do we do with the points is the question. without having like a bunch of switch case logic. Oh, very nice rain going on. Very nice rain. We've already gotten further than I thought that we would go. So that's good. Oh, I'm supposed to also multiply this times t before we forget. The problem I have is if I have two of these points, if I just get two of these points out of this function, then what does it mean to me? I'm trying to like split up the triangle in my head, right? Like, how do I split it up? I'm trying to like think of it in my head, like what it looks like. It depends on how it ends up going, right? Well, actually no. Actually no. Because if you have two on the side, you're always gonna have two on the side that you cut and one on the side on the other side, right? Like that's the only way it could happen. So when you cut down the middle, all you need is this one wound a certain way, the other one wound that way, and then this one just with the new points. So it's the one odd out with the new points, and then it's the two that weren't odd out. One has two new points, and the other one just has one new point and the other point. So that's the only case. So we're guaranteed to have two new points. So let's just have vec3 new points. 2. We're guaranteed to have two new points. New point count. Just be super explicit with it. And we will have new points, new point count plus plus. Okay, this is getting to be quite ridiculous. I recognize that. Let's just do this. So that it's very simple for us to read. I mean, it's still not very simple for us to read, but whatever. Okay, so we have two new points. So the one that is the odd one out. Oh, dA doesn't equal... Oh, hold on a second. Oh, hold on a second. Hold on a second. It's not dA doesn't equal dB. Let's also... I need to know which one is the odd one out. Um, Jesus. Whoa. 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 Whoa.